This video covers section 5.6, Applying Exponent Rules, Scientific Notation, Objective 1, Convert Decimal Notation to Scientific Notation. The reasoning behind the need for scientific notation is when you look at very large objects like the sun, its mass is such a large number that it's so cumbersome to write down. So we like to write it in a better way, and that is scientific notation. If you look at something that's extremely small, like the mass of a dust particle, that number is so small that it's so cumbersome to write down, we need another way to express that number, and we use scientific notation. Scientific notation. It is a number written as the product of a number, x, where x is greater than or equal to 1 and less than 10. And then a power of 10 goes with it. This is said to be in scientific notation. That is, if you have a number that looks like x times 10 to the nth, where x is greater than or equal to 1 and less than 10, and n is an integer, that is said to be in scientific notation. So we can write that very large mass of the sun in a shorter, more succinct way as 1.989 times 10 to the 30th kilograms. The mass of a dust particle can be written as 7.53 times 10 to the negative 19th kilograms. So one thing that becomes apparent right off the bat with scientific notation is that very big powers, positive powers, mean large numbers. And negative exponents mean very small numbers. And that's the way I like to approach scientific notation. If we're going to write a number in scientific notation like 10,302, I need to make sure that my first number is in between 1 and 10, including 1. And so I think about where the decimal is, and I can move that decimal until I get it to be a number between 1 and 10, and that goes in between the 1 and the 0. Now I need to offset that movement by stating how many times I moved it. I moved over once, twice, 3 times, and 4 times. And if it's a big number, like 10,000 is a big number, use a positive exponent. 1.0302 times 10 to the 4th. Whereas 5,432,000,000, my decimal sits here. I have to move it over 3, 6, and 9 spaces until I can make the number be between 1 and 10. 5.432 is between 1 and 10. Now I offset that, or I make this equivalent by multiplying by how many spaces I moved it, which was 9, positive 9, because we have a big number. And when you have small numbers, you move those decimals over to the right. 3, 6, and 7 spaces would put me at 45.9. If I moved it 8 spaces, it'd be 459. So I need to be careful and make sure that my number is between 1 and 10. So there's 1 space, 2 spaces, 3, 4, 5, which would be 0.459, and 1 more is 4.59. That's the number between 1 and 10, and I moved it over once, twice, 3, 4, 5, 6 spaces. So I multiply by power of 10 with a 6, and since it's a small number, we use negative. So big numbers, greater than 1, use positive. And small numbers, less than 1, use negative exponents. Greater than 1, use positive exponents. So I don't even want to read this number. We got a bunch of zeros and then a 9, 0.00, a bunch of zeros and a 9. So I move it all the way over until I can get it to be a number between 1 and 10. And that's going to be the 9.0, or to the right of 9. 9 times 10. And now I have to count how many spaces I moved at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the 10th, but we use a negative exponent because it's a number less than 1. So 9 times 10 to the negative 10th. This concludes the video for section 5.6, Applying Exponent Rules, Scientific Notation. Convert decimal notation to scientific notation.